So now, since you're very clear how to find the trigonometric ratios for 30 degrees, 45 degrees and 60 degrees, let us move on to finding the trigonometric ratios of 0 degrees and 90 degrees. See, frankly speaking, the finding the trigonometric ratios for 0 degree and 90 degrees is more about visualization. If you can visualize the triangle well, that how the angle and how the sides are varying, then finding the values of 0 degrees and 90 degrees trigonometric ratios for them will be quite easy. So let us start with 0 degrees. Let us see how the values are derived for this. Consider a triangle, a right angle triangle. Okay, say I have this a right angle triangle ABC. This is A, this is B, this is C, this is right angled at B, and say this angle is theta. Okay, so this is my perpendicular, this is my base, this is my hypotenuse with respect to theta. So now I can write the trigonometric ratios with respect to this, that sine theta is equal to perpendicular by hypotenuse, cos theta is base by hypotenuse, tan theta is perpendicular by base, and so on. That is quite easy. So now let us see how it will vary, how the values will vary for 0 degrees. So if I'm telling you that theta is equal to 0 degrees, can you visualize such triangle? Obviously, it won't be a triangle when theta will be exactly 0 degrees. So whatever we'll be talking about, we'll be considering that theta is very close to 0 degrees, right? Say, let us see how the triangle will vary when the theta will start decreasing. So let us consider scenario when theta became lesser than that, again smaller than that, again smaller, and a case will come that when theta will approach to 0, then this side, say this is a dash, a double dash, a triple dash, when theta is equal to 0 degrees, then this dotted line will coincide with line BC. Not exactly, but yeah, approximately it will coincide, because theta will be very closer to 0 degrees, and in that case the hypotenuse AC will coincide approximately with BC, right? So I can write when theta approaches to 0 degree, AC, the hypotenuse, approaches to BC. I'm not saying that they will be exactly equal, but yeah, more or less they will be equal. In that case, now let us see what is the value of sine 0 degree. You know, sine 0 is, the definition will remain same, perpendicular by hypotenuse. Okay. Now when theta is equal to 0 degrees, the base coincided by hypotenuse, and in that case the perpendicular became extremely zero, right? Can you just visualize it? That's why I told you in the very beginning that finding the trigonometric ratios for 0 degrees and 90 degrees is more about visualization. So as the hypotenuse coincides with the base, the length of the perpendicular will become 0, right? Now if the perpendicular is 0, whatever the hypotenuse is doesn't matter, because this value will become 0 itself. Similarly, cos of 0. Now cos of 0 is base by hypotenuse. Now when theta will approach to 0, the base is coinciding with the hypotenuse, and the length of both base and hypotenuse will approximately be equal. So this will be equal to 1. Hence cos 0 is equal to 1. Now tan 0 is simple, because tan 0 is nothing but sine 0 by cos 0. So this became 0 by 1. So this is equal to 0 degrees. Hence tan 0 is 0. Similarly, now if I tell you to find the other trigonometric ratios, cosec 0, inverse of sine 0, that is 1 by 0, which is nothing but equal to infinity or not defined. Similarly, sec 0, inverse of cos 0, 1 by 1, that will remain 1 itself. Tan 0, so cot 0, again 1 by tan 0, which is equal to 1 by 0, infinity. Hence, for 0 degrees, that is when theta will approach to 0, the values of trigonometric ratios are defined in such a way. Sine 0 will be 0, cos 0 will be 1, tan 0 0, and similarly cosec, sec and cot. So I hope how the derivation was done How the visualization was done is pretty clear to you.